This is the second video looking at solving equations, and we're going to do a little bit more difficult ones and work our way up from there. So if we've got more than one operation to undo, in the last one we just had one addition or subtraction or multiplication or division, if we've got more than one thing going on, we follow the same rule, and that rule way back up here was whatever we do to one side, we must do the same to the other. We have the same goal, which is isolate that variable. But we have an additional set of hints, maybe steps. First, any terms that don't have that variable in there should be moved to the other side of the equal sign. Move them away. I say get rid of them. Then continue like we do, use our opposite operation, so addition for subtraction or multiplication for division, to isolate that variable. So this one here, a over 2 plus 13 is equal to 12. We've got two terms, that term and that term on the left, and another one on the right. This one here doesn't have a variable in it. Let's get rid of it. Let's move it over there. In the last video, I showed this method of showing the work for that, where I would have a over 2 plus 13 and minus 13 would cancel out, and that would be equal to 12 minus 13, and 12 minus 13 is going to be negative 1. We'll get to the same point here in a moment, but I'm just going to show a different method for doing that. If I take this 13 and I say I want to move it over, some people will have been taught this way. When we move it over, that's fine, we just have to flip the sign. So we can say a over 2 is equal to 12. Bring the 13 over, but the positive 13 becomes negative, which is the same result as if we did it the other way. So 12 minus 13 is still negative 1. Just a different way to show it. Now I've got a over 2 is equal to negative 1, and there's only one thing going on. Is my a alone? No. What's happening? It's being divided by 2. How can I fix that? Well, I can get rid of that 2 if I have a 2 on the top. If I multiply by 2, so I can cancel. And then I would have a is equal to negative 1 times 2, which is negative 2. If I check back in the original thing, a over 2 plus 13 is equal to 12. Negative 2 over 2, that's negative 1. Negative 2 over 2 is negative 1. I add that to 13. Yeah, that's 12. Let's try another. 3 over b minus 2 is equal to 4. This term here, I don't like it. Get rid of it. So if I'll write it out the same way as last time, the 2 moves across and the negative becomes positive. So 3 over b is equal to 4 plus 2, which is 6. Now we're back in the nice situation we were in a moment ago. There's only one thing to undo. The problem with it, though, is our variable's on the bottom. So let's dig it out. If we remember back to the last video, the way we dug that out was we multiplied both sides by that variable. That canceled it out on the left side here, and now it's on the right. So I've got 3 is equal to 6b. Feels like we're in no better of a situation, but we are, because now the b is not on the bottom of a fraction. Now I look at my variable. Is it alone? No. What's happening? Multiplied by 6. How do I get rid of it? Divide by 6. So those 6's cancel out, and 3 over 6 is a half is equal to b. 3 over 6 just simplifies to a half. And if we check in our initial thing, 3 over b minus 2 is equal to 4. 3 over a half, 3 divided by a half, is the same as 3 times 2, which is 6. And 6 minus 2, yeah, that's 4. It just balances out to our right-hand side. We're okay. Let's do some more here. 4x plus 6 is equal to 0. We've got this term. It doesn't have a variable in it. This one does. Let's move this one away. 4x is equal to, the 6 comes across, but the sign changes. 4x is equal to negative 6. For those of you who prefer the other way of showing the work, I'll do that here. I would say subtract 6 from that side, subtract 6 from that side. That's, oops, just 4x left over. These two are gone. And 0 minus 6 is negative 6. So it's the same. 4x is equal to negative 6. Now I look for my variable. There it is. Is it alone? No, it's being multiplied by 4. So in my 4x equals negative 6, I'm going to divide by 4 on both sides. That's the only rule I need to follow, but I do need to follow it every time. Those 4's cancel, and negative 6 over 4 reduces to negative 3 over 2, or negative 1.5. I'm going to write out negative 3 over 2, because that's what I like, and nobody can stop me. If we check, 4 times negative 3 over 2 is negative 6. If we add 6, yes, that's 0. Next, z plus 1 over 2 is 3. Is my variable alone on one side? It's not. I've got this plus 1, which is really tempting to move out of the way, but it's not just plus 1, is it? It's over 2. This 2 is dividing not only z, but also 1. The best thing to do here, not the only thing to do, but the best thing to do here, is to deal with this common denominator for the z and the 1. Get rid of it. I'm going to get rid of it the same way I would get rid of it in any other time. Multiply the left side by 2 so that I can cancel, cancel. I drew brackets here around z plus 1 just to remind myself that this 2 really is being multiplied by z and 1. I don't have to actually go through and distribute because I'm canceling it right away. But it's a good reminder because that's an easy thing to forget. So now I've got z plus 1 is equal to 3 times 2. 3 times 2 is 6. Is my variable alone yet? No, still has this 1 there. So let's get rid of it. Z plus 1 minus 1, that's just z. 6 minus 1, that's just 5. So we have z equals 5. And if we check our initial equation, z plus 1 over 2 is equal to 3. 5 plus 1, that's 6, divided by 2, yes, that's 3. We'll do 2 more here before we probably run out of time. 3n plus 4 over 8 is equal to 2. 3n plus 4, there's our variable. We want it. It's being multiplied by 3, 4 is being added, and it's being divided by 8. This one here I'm going to get rid of first. I don't have to. I could rewrite this like that, and then I could move this out of the way, and then I could deal with the 8. But it's just going to make more work for myself to do it that way, so I don't want to. Instead, I'm going to get rid of that 8 first. I'm going to multiply the top, the whole top, by 8, and I'm going to multiply the right-hand side by 8 as well. We can cancel out those 8's. We can get here 3n plus 4 is equal to 2 times 8, which is 16. Is my variable alone yet? No, there's still 2 more things to do. So I'm going to take this 4 and get rid of it. Subtract 4, subtract 4. We only want one term with a variable in it, and we want it on one side of the equal sign. Dealing with the coefficient can come last. So now I have 3n equals 12, still not alone. I need to divide both sides by 3. Why do I want to divide them by 3? So I can cancel out that one. I wish this one was gone, so I just make it happen. And as long as I do the same thing on the other side, it's okay. Just remembering to never break that rule is sometimes easier said than done. 12 divided by 3 is just 4. It should be 4. And if we check our initial equation, 3 times n plus 4 over 8 is 2. 3 times 4 is 12. 12 plus 4 is 16. 16 divided by 8. Yep, that's 2. Last one here. We've got 3/4 b plus 6 is equal to 10. My b is right there. I've got some choices. I could take this 3/4 and distribute it to the b and distribute it to the 6. If I do that, I end up with, what, 3/4 b and 9 halves 6? 9 halves, so 3/4 times 6 is 9 halves, which is what, 4.5? I could do that. I could end up with 3/4 b plus, right, 4.5 this way, 9 halves is equal to 10. I could move this one out of here. So 3/4 b is equal to 10 minus 9 halves. 10 minus 9 halves, 10 minus 4.5 is 5.5. So for 5.5 equal to 3/4 b, b still wouldn't be alone. I'd still have to divide by 3/4 so that I could cancel out 3/4 and 3/4. As long as I remember to also divide this side by 3/4, I'm okay. 5.5 divided by 3/4 is still the same as 5.5 times 4/3. At any rate, it's going to be 7 1/3. I'm going to write that down up here. 7 1/3, or if you wrote it out as 22/3. Well, same. But I'm going to show the work a different way, which I actually prefer. And maybe you'll see why I prefer it, or maybe you won't. Maybe you don't care. I don't know. Do it anyway. You can't stop me. I'm in a video. So 3/4 b plus 6, I'm going to say this 3/4 is doing nothing for me. I would like it to be gone. I'm going to divide by 3/4 now. 3/4 divided by 3/4, those guys are gone. And now on the left side, I've just got b plus 6. I don't even need to put the brackets in because there's nothing to do with them. And on the right side, I've got 10 divided by 3/4, which is the same as 10 times 4/3, which is 40/3. I'll just write it out that way. Now I just have to get rid of that 6, right? And now I have b all alone. So if I subtract 6 there, subtract 6 there, I could write it out that way or that way, it doesn't matter. B plus 6 minus 6 is just b. And 40/3 minus 6/1, we'd have to find a common denominator, which is going to be 3, obviously. So 40/3 minus 6/1, I change it to common denominator of 3. 40/3 plus 18, or sorry, minus 18/3. 40 minus 18 should be 22. So I get 22/3. That's what I had over here. You don't have to show this out. If you know how to do this on your calculator, you don't have to show that work. But here it is. I like this one because look how much less work that was. I got rid of this fraction early and profited thereby. Okay, I'll do probably one more video here tonight. See what else we can do maybe in the future.